Hello guys and welcome to the next tutorial on GNU Simulator Intel 8085. In this tutorial we are going to learn about basic operations like addition or subtraction upon 8-bit data from a specific memory location. The data will be stored in some specific memory location. So let's start. For convenience I have already stored some data in memory location 001 and in memory location 002. Now we are gonna add this to from the previous lecture or tutorial. You can already know to load some memory, load some data from memory. We have to use the LDA command, and to store some data from memory to from accumulator to memory, we have to use the STA command. So we are gonna use it in here. First of all, the LDA program, LDA instruction, LDA 00001H. Then for our convenience, we will move that data, basically copy that data from accumulator to another register for safety. Otherwise the data will be lost. Now again we will load the data from memory location 0002H, and now directly we are going to add that data of the register B with accumulator. Then STA will store the data in 0003H and halt. So let me just process this step by step. So first it will load the content of 0001. Now we are moving the data from accumulator to B register. That is, we are just copying a data from accumulator to B register. You can see here just a copy was made in B register. Now again we are moving some data in 09, that is 09 in accumulator. So basically we are moving this data so that it will not be destroyed. Actually any subtraction or addition method or process or operation will be done in accumulator. So for that we have storing this data in some auxiliary position like in B register. Now we are adding this register content directly with accumulator. So the equivalent decimal will be like 14, you can see here. So and now we are storing it in the position 0003. Now in this programming or in this way of instructions, first of all these are LDA and STA are 3-byte instruction, and move and add or halt are 1-byte instruction. So it will take total 3 plus 1 4 plus 3 7 plus 1 8 plus 3 11 plus 1 12, total 12 byte of memory. That is way too much. So for betterment we are use some other method. Let me write it. So we will be using the method or the instruction like LXI H 0001. So what is LXI stands for? It stands for load the content of the memory to the specific register pair. We have already mentioned the register pair 8, that it will store the content in register pair HL. Not the content, it will store the address into the HL pair. So before we proceed, let me reset the registers. Now LXIH001H will store this address in HL pair. Now let me move this content of the memory into accumulator. Now INX, that is stands for increment the register pair with 1, means it will just simply add 1 to it, then directly add the memory with it, and again incrementing that we are storing mm, so basically again or again and move the content from memory to a register, a register to memory, and halt. Now LXI command will contain the HL pair, the address 0001, you can see, and we are moving this moving the content of this memory in accumulator now. Sorry, um, and this is it. You can see that the accumulator content is now the 0001 positions content. Now incrementing the register pair, that is pointing now 02. This is basically pointers in C that will point some address, specific memory address. The same concept is used here. It will pointing the address of that memory location, and it will now add the content of this memory location with accumulator content, and the 14 is now stored in accumulator. So we are again incrementing that register pair in 03. So there is already data stored, so we are again incrementing it, and that is 04, and we are moving now the memory to accumulator to memory, and this is how you can see again the content of 0004 is 14 now. So in this process LXI is 3 byte instruction only, otherwise the other instructions are 1 byte instructions. So total 3 plus 1, 4, 5, 6, 7, 8, 9, 10. Total 10 byte instruction. Total 10 byte memory locations, memory is needed for that. That is more convenient than the previous one. You can just simply use INX H once here also, as in it is already stored in third memory location. So I am incrementing it again and storing it in 4 location. Otherwise you can also store it by incrementing once. So in this way you can add some data, 8-bit data, and similarly you can subtract some data, but you have to use the sub command instead in the place of add command. So I'll leave that as an exercise for you. So thank you for watching my video, and please subscribe my channel and keep watching.